Okay. So let me see how many are in the stream. Right, okay, so there's 7 joined. Okay, what I'm going to do, guys, I'm just going to give it another, say, 2 minutes, and then we'll take it from there. Excuse me. Okay, guys, 1 more minute, and we'll start. Yes, Darren. We had a tablespoon of coffee in the mug. So, yep, I'll be reading that one. As you can see, guys, I'm just opening up these schematics. Okay, so I need to just check to see what's going on. Stream. Right, cool. That's fine. Yeah, that's probably the best I can get it. I think, yeah, so that's me pretty much full screen. Yes, Simon. Yes, Josh. So I ate roti and curry chicken for lunch. Can't drink coffee now. I'll do the yeah. Yeah, some funny comments there in the chat. Keep them coming, guys. Keep them coming. Appreciate it. Yo, nice old commander. Welcome. Apparently, my son is in the chat. Yo, is that you then? Right, okay. So we're going to start, guys. Okay, so it's 7:40, so we're 10 minutes over. Okay. Right. So what we're going to do is start off with what we're going to talk about today. So, um, I know that a lot of you have been, probably. I mean, we all have different sort of, like niche, sort of niches, that we like to sort of work on. So some people like to work on laptops, some MacBooks. Some will like to work on, like, say, like, I don't know, like iPhones or Samsungs or consoles. Yeah. So what I like to do is basically, oh, we try not to focus on like one thing. So we'll train on MacBooks, and we'll move on to laptops, then we'll move on to iPhones, and then Samsung and iPads, and then data recovery, hand skill, and then we'll cover a lot of different sort of, categories, within sort of the industry, and also I'll be doing like sort of business teaching and marketing, all that sort of stuff, how to make sort of more money, how to sort of, increase your actual sort of turnover. So just things like that. So yeah, hopefully it will be beneficial to sort of all of you. What I would say is that, I mean, you could focus on like one type of repair, but what I find is that, what if you get quiet one day, or a couple of days, or 1 week you're really quiet, and you just focus on like those particular jobs. But if you have a varied skill set, say you work on MacBooks, iPhones, consoles, then you're going to have a sort of, like a varied, um, amount of jobs coming in. Things like even having like a screen protector machine in stock, just to sort of cut your screen protector is handy. Doing like phone unlocking, FRP unlocks. So in my training, I do cover quite a range of different sort of topics. So if there's anything specific that you want to learn, just obviously let me know, and I can sort you out with that. So let me just update the chat a wee second. I just need to check something. Okay, Zane. So I'll catch you later, buddy. I fixed a connector, a lamp for a customer. Does that count? I suppose it does. Right. Okay. So first things first. Right. We're going to look at the sort of MacBook schematics. So what I want you to do is I want you to actually look at two different schematics here. So you've got 820-00850 and 820-928. So, guys in the chat, if you haven't got these two schematics, you can download them from Badcaps. Yeah. So what I'm going to do is just open up my notepad here. So if you go to badcaps.net, if you haven't got an account, get an account and download these two schematics. 820, 820. Okay, okay. Okay, guys. So that's probably what your first step is going to be. Is you're going to be wanting to get the board view and the schematic. Yeah. See. So what we're going to look at is these two boards. Okay. MacBook. So MacBook. 820-00928 and 820-00850. Okay. So the 850 is going to be the A1989 model. Okay. So the A1989 model, right, is going to be 2018 to 2019. Okay. And it's going to have a T1 chip. Okay, T1 security. All right. So the 928 is going to be the A1707, right? And that's 2016 to 2017. Okay. And that's get the T2 security. All right. So if we have a look at, first of all, let's have a look at the 00850 A1989 board. So if we open up the schematic, first of all, I'm going to look at the 850 board. And if you look here on the first page, so I'm at page 1, and we go down, we can see here, it shows you here T151, T139. Yeah, so that's the T1. All right, so 850 is the T1 chip. T1, okay. So then we're going to look at the schematics for the 928, right? So 928, if we scroll down, you've got here, it says T2, yeah, T208, T2, right? So that one's going to be 00928 A1707, and that was made 2016, 2017. That's the T2 security chip. Okay, look. So I hope everyone is sort of following so far. Okay, so right across the board, right, these support Retina display. Okay, you've got True Tone. You've got 720p HD cam, right, with FaceTime, so it's front cam, right. So you get 16 gig RAM on all these models, yeah, on both these models. You've got Thunderbolt. 3 USB-C Gen 3, yep, sorry, USB-C 3.1, and it's Gen 2, okay. And basically that supports charging and display, yeah. So what I'm going to do is I'm just going to make this writing smaller so I can get more on the page. But what I'll do is I'll send this to everyone who's in the training. Let's see. Right, okay. So I'm just going to condense this. Right, so that should be okay. Right. So next, so we're looking at sort of support, OS support. Okay. So OS support. So we're looking at the A1708. Okay, guys. So the A1708 and the 06. Right. 2016. Right. Will support up to Monterey. All right. So we've got here the A1, right, 706, the 707, and the 708. Okay. We have here 2017. Okay. And that supports up to Ventura. Okay. So the A19990, right? 2018. And the models A1990, A2159, A1989, and yeah, it's going to be 2019, right? And that's going to be cinema, right? But also, what we can do is, if you don't have those latest ones, then you can use Sierra or High Sierra. So the 2016, 2017 will take Sierra, right? And the 2018, 2019 will take High Sierra. Okay, okay. So does everyone understand that and get that so far in the chat? So any questions so far on the chat, guys? So I've got Louis, Dodiomi, I've got Phone Medic, Abdullah, Bunick, Teebs, Darren, Simon, Josh. Yep. No questions. Okay. So that's fine. So I'm assuming you are following that since there's no questions. um, so the A1 708 2016 model has no T1. Right? It just has an SMC. Right? So the A1708 2016 model has no T1. It just has an SMC chip. All right. So just be wary of that. Okay. So 11 July. Can't believe it's 2023 already. Okay, guys. So following so far. So Simon, all good, mate. Darren, thumbs up. Bunick, Rahim, all this note you can share after. Yeah, but you should be taking your own notes as well. You know, get a pen and get your notepad and take your own notes. It's you know, but it's not like kindergarten or nursery. You know, but yeah, I'll share it, no problem. But right, okay. So if you just want to maybe get your notes ready or get a wee pen or something, or you know, I can give you maybe a few moments to do that. Um, so this is probably like like the basics, of these two models. So what we're going to do is we're going to look at some sort of common problems, common issues, in relation to that sort of these models. Okay. So let's go down, right? And we'll create a wee line here like this. Okay. What I'm going to do is just start off with 2016, right? 17, right? So we know, right, that that's a T1, okay? And we know that that's going to be A1 706, A1 707, because remember the A1 708 from 2016 doesn't have a T1, it just has SMC. All right. So the first thing we do is when we check, obviously the T1 chip, is that we check the working conditions of the MacBook. Now, I only go through the working conditions on the official training. I don't go through it in the free training. Okay, so you can obviously after this you can message me directly about the sort of paid training and yeah, I'll explain more. So first we always check the working conditions of the motherboard before we start troubleshooting certain ICs or certain chips. So the T1, okay. So the T1 model, so the T1 is going to be in charge of camera, right? It's going to be in charge of like touch bar, okay. It's going to be in charge of touch ID. All right. So basically, the touch ID data is inside the T1 chip. Okay. So say if camera, touch bar, touch ID damaged, and change the T1 chip. Okay. Okay, guys. So what we can do is we can take a T1 chip from a 2017 board and install on 2016 board. Okay, but we cannot take a 2016 T1 and put on T2. Sorry, put on. We can't take the 2016, put on a 2017. Sorry, my apologies. So we can take a T1 chip from a 2017 board and install on a 2016, but we can't take a 2016. So we can't go upwards. We can go downwards, but we can't go upwards. Okay, guys. So we've got here, Louis says yes, Josh says yes. So everyone's following so far, yeah? Yep, so just going to recap, right? So just so that everyone understands. So we're looking at a couple of MacBook models, 00850, 00928. And the A1989850, right? So that's 2018 to 19, and it's a T1 security. T1 security. 00928, A1707, 2016-17, T2 security. A1708, 2016, no T1 chip, only SMC. Okay. All of these models have Retina display, True Tone, 720p front cam, FaceTime, 16 gig RAM. Okay. Thunderbolt 3, USB-C 3.1 Gen 2, charging, which supports charging and display. Okay. This is your OS support. Okay, so these models here is support Monterey. These ones support Ventura. These ones Sonoma, and also on 2016-17 you can use Sierra, and 18 to 19 you can use High Sierra. Okay, so just to recap again, so 16 to 17 T1 model controls the camera, touch bar, touch ID. Okay. And the touch ID data is inside the T1 chip, right? And we call that the secure enclave, right? Part of Apple's secure enclave. So if cam touch bar touch ID damaged, then change the T1 chip, or can try to reball, right? And may work. So we can take a T1 chip from a 2017 board and install it on 2016 board. We cannot take 2016 and put it on 2017. T2 security chip is the same as A10 CPU from iPhone, except the BGA, the ball grid array is similar to iPhone 6. Okay, so the T2 and A10, same thing, but the balls are like the 6 iPhone 6, you can say. Okay, So I hope you are following that so far. Let me see what the chat's saying. Why can't you go down? So this would be because of Apple security. So basically, you have BIOS data, you have ROM data, and yeah, there's probably some sort of security that Apple have put in that you can't downgrade, which is a bit, crap. But that's just Apple for you, as we know. Right. So you've got 11 in the chat. Right. So Josh, yep, excellent, Josh. They're following, bro. Well done. So we're going to look at the T1, right? A1706, just briefly. Okay, so A1706, for example. Okay, say for example, so 5-volt stuck on USB-C. Okay, so I'm assuming that we're not all beginners here and that we do know what a USB-C meter is. Looking at the chat, yes, Louis. So cam or touch bar or touch ID damage, yes. Replace the T-chip or rebuild. No, you don't have to replace the camera and the touch bar. What you would need to do if you have a problem is that you need to flash the BIOS. Okay, and that should fix it. If you still have a problem, the touch bar, sometimes you need to you have to actually upload the serial number again, or install a clean BIOS. So on and a lot of the modern sort of laptops and MacBooks, within the BIOS we have something called the ME. So the ME is like a management engine built into the sort of BIOS, and the PCH. So the BIOS, the PCH, the SMC, the ROM, like USB-C ROM, the T2 ROM, they sort of all talk to each other. So if you flash the ROM, fix the serial, clean flash the BIOS, clean ME, then it should all be fine. But we're going to go into the tools in more sort of detail as we go along. But that question, we are going to go on more into detail about, what we need to do based on, like, for example, if we have to change the T1 or the T2 or the SMC, then we might have to replace, maybe like Touch ID button or camera or whatever, but no, we can fix a lot of things by flashing like BIOS or ROMs or whatever. Right, so going back to that's a good question, Lee, but thanks for that. So A1706 5-volt stuck, okay. So 5-volt stuck on USB meter, right, and 0.065, right, on DCPS stuck, okay. And that's basically, it's not boosting to 20 volt, okay. All right, so the first thing that we do is that we need to diode mode. Well, obviously, we take some steps first of all, like new charger, right? New USB-C flex connector, okay. So we obviously check these. First of all, we replace these, and we still problem. And what we would do is that we would diode mode the USB-C connector. Okay, so what I'm going to do is I'll open up 928, right? Just an example, okay. And what I'm going to do is I'm going to look at the primary USB-C controller, which is U3100. That's the USB-C chip. So the connector for that USB-C chip is this one here, JAI 3300. Okay, so the USB-C connector is JAI 3300. It's called. So we need diode mode the pins. Okay, so the best way to diode mode those pins, right, is using a tool called the SUEM2. Okay, USB-C tester. Okay, so what I'm going to do is I'm just going to start. I'm going to open up a page, and yeah, we'll actually show you what the SUEM2 looks like, and yeah, what it does and whatnot. So okay, guys, yes. Right, so this is the box here. Okay, so basically you can, first of all, it's a Mac USB-C and EVP meter, right? So you can test the display connector for diode mode also. So you can check 2016 to 2020 MacBooks. You've got A1706 up to A2141. You can check the connectors, the USB-C and the EVP connector. You know, it's got an LED screen. It's got all the different sort of flexes. So yeah, it's a great little tool. So what we can do is we can watch this sort of video, and yeah, it will actually show you. Next, what we'll do is I'll fast forward it a little bit. If this will load up, it's not too fast, slow. So Pebes, yeah, 0.065 amps, so 65 milliamps. Yeah, Dodiomi. Nice. It's faster than just having to measure each pin compared to a reference value. Yeah, I agree. So if we look here, there's a discrepancy here. So a good value was 500, and he was getting a bad value 2400. So that points towards this here. So what he's doing, he's actually testing the EVP connector, the display, because he's getting no display. So on one side of the inductor here, you have diode value, but on the other side, there's no diode value. So that's how he solves it. You know, it was easy for him just to, you know, sort of diode mode that and check where the problem comes from. So that's what we use. So USB-C tester and EDP, yeah, which is the SUM2. So at the end of the video, what I'll do is I'll give you the contact details of the directly of the guy who actually sells it. So there's actually two guys who's in partnership, and yeah, I'll give you one of their WhatsApp, and I'll give you like a referral number. You'll get a discount. Okay. So yeah, USB-C, we have to test that in diode mode. Okay. So our main objective is to get 20 volts. All right. So basically on 2016, right, to 2018, we use CD32 15C00 USB-C controller chip. Okay, so that can be, so the USB-C controller chip is going to be, like I mentioned, U3200 on that side and U3100 on that side. On the other side, you've got UB300 and UB400. Okay, so there's 4 ports in total, 2 connectors in total. Okay, so U3100, U3200, UB300. Okay, and 2019 to 2020, right? CD3217B12. Okay, USB-C controller. All right. So what we do is, for example, we know, right, that this A1706, right, we spoke about previously up here, is going to be, yeah, obviously 2016, 2017. Some of them can be older, some of them can be a little bit newer. It really just depends on the model, you know, that you're actually working on. So if we have a look here, let me see. I'll just show you this chart here. Right, so we have A1706, right? A1706, we have it in a 2016 and a 2017 model, like I said. Okay, so A1706 comes 2016, 2017. Okay, A1706. All right. And yeah, so that correlates with this one. So we know that the A1706 uses the CD3215C00. Okay. So what we can do is just add that in here, right? So what we want to do, right, is obviously once you check the diode mode and if it's okay, which probably won't be, but if it's okay, what you can do is you can check the CD3215 for shorts, you know, and round about the IC. Also, you can check the LDO. So it generates its own LDO, so you can check those LDO voltages, okay? And that's what I would do. You can also check the thermal camera to see if there's anything getting hot spots. Okay. So there's, if you need decent USB-C ICs, then again, let me know. Because if you have problems yourself, then we can get you decent ones. So yeah, thermal camera, you can check hotspot. You need to check working conditions, you know. So you need to check working conditions of the charging circuit, right? So if you change, say for example, you change the CD32 chip, and you still have the same problem, then sometimes it's good to replace like the pair on that side. Some people actually replace like all 4 chips, you know, so you can replace single USB-C, you can replace it in pairs or all 4. Okay. So in future trainings, I will actually explain which chips are actually supported for which boards, because sometimes you need to replace all 4. Sometimes you need to replace 2 as a pair. Sometimes you have to take them from a donor board. Sometimes you need to program them. So in future sort of trainings, then yeah, we're going to go into sort of more detail in that sense. So Timon says it's a great piece of kit. I'm going to order one. Can you buy these chips or need donors with both? Wonder if you flash the T2 chip with another Mac with no USB-C port. I don't get that because all the T2 chips have USB-C ports. Oh, you mean if it was like USB-C port is faulty? Not that I know of, mate, because you need the FU mode, and yeah, you need the USB C connection. So yeah. Right, moving on. Right, okay, so we're moving on. Right, so replace single USB-C, replace the pairs. You can replace all four. Right. So what we're going to do is look at the circuit in more sort of detail, right, on this step here. So we have the CD3215 C00. Okay. The next chip, right, is the charging IC. Charging IC, which is the ISL 9239. Okay. Right. So so this chip gives the CD3215 gives power to the charging IC. Charging IC gives power to the ISL. Right. The ISL gives power to the SMC. Right, so the charging IC is the ISL. Okay, just put that in brackets. Right, so remember, so that's power. Okay, so we're going to focus on power. Right, so the CD32 is giving power to the charging IC, which is ISL 9239. Okay, and then that gives power to the SMC. Right, so on the T1, the SMC is outside the T1 chip. Right. So the SMC. So let's go down here. Power. Okay, so USB-C chip gives power to the ISL. ISL gives power to the SMC. Okay. And then the SMC then talks to the CD32 chip again. Right. And this time, data. Right. Okay, you following so far? So USB-C power to the ISL, that gives power to the SMC. Once the SMC is powered, then the SMC then talks to the USB-C chip. Okay. And USB-C ROM. Right. So actually, the CD32 chip has its own ROM. Okay. So this is data. Okay. Data. Okay, guys. So is everyone following so far? Who's slacking? Let's see who's slacking. How to check Dodiomi, how to check also ROM from CD32 in case it's a problem. Yep, good question. So you remember I spoke about the working conditions, yeah? So you check these one at a time. So you check the CD3215 first. That gives power to the charging IC and make sure that's outputting power. If it doesn't, check the working conditions. Okay, because it doesn't necessarily mean that the charging IC is bad. Check the enable signals, check the data lines. Because remember, the charging IC talks to the SMC. right? So if the SMC is bad, the BIOS is bad, USB-C ROM data, it's not going to charge, So, yeah, you need to sort of look at these things. Obviously, the 3D32s could be bad. The USB-C connectors could be bad. The charging cable could be bad. Okay. So, Doriomi asked a question. So Louis said yes, Dan yes, Sai says yes, Team said yes. So yes, and you can take test point and check ROM corruption. Yeah, but we're going to go into that, mate. You don't need to use test point. There's another way we can check corruption. Right. So basically, USB-C ROM data, right, is SPI. Okay. So we have MOSI, MISO, clock, right? VCC, ground, write protect. Okay. So we have these lines on SPI, right? So we can check if there's clock, right, using the oscilloscope, right? We can check if there's data being sort of sent from the master. We can check if data has been sort of sent from the slave. We can check if the ROM has got power. So we can use the oscilloscope and the logic analyzer for that. Okay. And what we can do is that you can actually check a donor board and compare it on yours. Right, that's one way of doing it. But obviously you need to know what a working board looks like. Okay. So in future trainings and the paid training, I will show you on the oscilloscope what the signals look like when the BIOS is actually, or the ROM is actually sending and receiving the data. Okay. So packets being sent, yeah. So yeah, it's important that we check, for especially the acknowledgement bits, So obviously, if we're receiving an acknowledgement, it means that the data is actually being sent, and if we get an acknowledgement from both master and slave, then yeah, we could say that there's data sort of going back and forth, but the data could be corrupted, so it's difficult to see that. But what you could do is check a working board and see what the data looks like compared to your board, and if it's the same, then it should be okay. But because it's stuck at 5 volt, it will be different. So what I would recommend is probably getting something like the Rigol. It's the 11504Z, I think it is, something like that. So yeah, that would be a good beginner scope, I would say, to get. So yeah. So basically, this section here, this is stuck on 5 volt, right? And the reason why it's stuck on 5 volt could be the charger connector, could be liquid damage, could be the charging IC, the SMC, USB-C ROM. So you really need to check the working conditions, check power that's going into chips, check the enable signals, check the data lines, because, like I said, the CD32 talks to the ISL. That's already sends power to the ISL, then that sends power to the SMC, right? So if you don't get power at the charging IC, then it's not, you're not going to get 20 volt. So you have to check things one by one. Okay. So I'm going to show you. So need to enable protocol decoding. That's if you want to decode, but it's probably not important unless unless you actually know the addresses. So if you know the addresses, then you can see if which chips are actually working, which chips are not working. You can do a bus scan, and scan the full sort of bus for all sort of chips on that line. Also tap CC1, CC2. So basically the CC1, CC2, they're just detection pins. Okay, so they're just detection pins. Does the USB-C ROM have its own chip or part of the CD32? Yeah, it has its own chip, mate. So I'll show you that just now. Okay, so we're going to move on to the next part, and yeah, we'll look at the USB-C ROM. Okay, so yeah, there's actually another chip between the SMC and the ISL, right? And it's like a mini power IC, right? So, and that's usually called U6903, right? If we search for it here, okay. So that's a 3V3G3H HD hot. Okay, so that's actually U6903. Okay, so we need that. All right. So if we look at that on the schematic, right? If you notice here, right. So the top line here is the 5 volt from the charger, and this is PP bus from the battery, right? So if your battery voltage or USB-C voltage that goes into here, and that creates 3.3 voltage. Okay, so if you go back to the notepad, VV3. Right, so the charging IC enables the U6903. Okay. So stuck on 5 volt USB-C chip, right, gives power to the charging IC. Okay. The charging IC enables U6903. Okay. U6903 gives power to the SMC. Right, and then the SMC communicates with the USB-C chips. Okay, right, so power, enable, yeah. Okay, so you have to look at it in this way. So if you look at back to the schematic, well, I'm going to show you the USB-C ROM chip. Okay, so the USB-C ROM chip is actually going to be, so USB-C ROM Okay, so one pair on one side equals one ROM chip. All right. Same for other side, right? So the other pair, the USB-C ROM, yeah. So the other pair on the other side will have its own USB-C ROM chip, okay? So the location of that is usually here, okay? So it's U2890 on one side. So the U2890, right, that's for the 820.00928 board. Okay, that's the left side. Okay, so that's here, see that U2890. Right, so if we go to the other side, the ROM on this one is going to be on this side. So look, yes, normally here somewhere. Yeah, it's actually it's hiding. Right, so what we'll do is that the way that I check this is, say we go to the USB-C. Okay, so UB300, UB400. Let's click on this one. All right, and you've got here Meso and Mosey. Right, but we can check on the schematic, right? So it's UB090. Okay, so see how there a search for U2890. Look, it tells you in the bill of materials, right? So the UB090 is the, yeah, so it's right at the top on the right side there. Okay, and that's what the line is called. So see how it says TBT? Actually, it goes through the Thunderbolt connect IC first of all, and then it goes to the USB-C. So see if your Thunderbolt is bad, then you'll have a bad USB-C chip as well. You know, so that's another thing that we need to sort of check for. Um, the right side ROM. Okay, so from the ISL to the SMC enable. Yeah, yeah. There's reset lines for most chips. Okay, but once it enables from the ISL, it starts U16 to give the SMC like it's always on. Yeah, that's right. Yeah, this SMC won't get power until the U1603 is enabled, and then that gives power. Well, it creates the power rail. So if you look at the power rail and check where it goes, and then it'll be clearer. right? So first of all, somebody asked, I wanted to answer the question 101. So USB-C ROM, okay, somebody asked about the data. So if we go to U3100, okay, that's the USB-C primary chip, right? So USB 3100, CD 3215, right? We have here clock, MOSI, MISO, and that last one is probably going to be chip select, right? So what we can do is we can actually copy that, put it in here, okay, and what we'll find is we'll find that there's pull-up resistors, okay. So let's search for them. Okay, so here we go. So it's actually taking us to the UB090, right? So if we look at this here, chip select, and if I put it in here, the search, let's search for it. Okay, so we have these resistors here, 100 ohm, 15 ohm. Okay, so what you would need to do is you need to check. You would need to check to see, right, is these resistors get the right voltage, and is it the right voltage as well? So remember, these are pulled up using like 3 volts or whichever power that's going into the ROM. So if it's 3.3 volts, it will be 3.3 volt be pulling up on these resistors. But make sure that you actually measure the resistors, okay? So if you see here, that's in, out, because that's master in, serial out, slave out, clock in, chip select in, all right, MOSI, MISO. So check those resistors, okay? Because there may be a fault there, and that's why the USB-C ROM is not working. So this side of the ROM is called TBT TSPI CSL. Okay. But if we copy this, this will take us towards the chip. See there? So this is the right-hand side of the board. Okay. So you see that here. So USB-C chip is communicating with the USB-C ROM. Okay, guys, through these lines, through the resistor. It could be bad resistor, it could be bad ROM chip, it could be bad data, you know. So what you could do, right, is you can actually replace the ROM from a working donor, right? Also, you can flash the ROM, okay? So what you can do is you can flash the ROM using like a programmer, okay? So remember, we would do this when either it's stuck at 5 volt or it's going up and down, 0, 5, you know, 0, 5, 0, 5. That could be another issue, right? Or okay. So most of the time, if 5 volt jumping, then it's a USB-C ROM issue. Okay. So if it's like go 0, 5, 0, 5, 0, 5, and the amps is jumping up and down, then I would definitely flash the ROM. Okay. If T2, then also flash the T2 ROM, okay? Because the T2 got its own ROM chip. Okay. So I've explained the continuity process and obviously checking, between the USB-C chip and the USB-C ROM. Okay. Right. So the ROM needs 3.3 volts. So if it doesn't have that, then it's not going to be working. So you would still obviously check the working conditions. That hold signal there is 3.3 volt as well. That's just like a power supply hold. All right. Let's see. Right. Okay. So I want to go through more of the troubleshooting of the 5 volts. Okay. Uh, so so first of all, right, T1, right, has no DFU mode. T2 has. Okay. You got that? Everyone following so far? We have 7 left in the chat. So T1 has no DFU. T1 has no DFU. T2 has. Okay. So just sort of be wary of that. Okay. So 0 to 5 volt to 0, right? 0.035 to 0.060 to 0.030. Okay, jumping equals USB-C ROM. Bad, right? Or the data is bad. Okay. So check resistors, continuity, voltage, oscilloscope. Okay. So this is T1, right? T2. So 0 to 5 to 0. Okay. 0.045 to 0.080 to 0.045 jumping. USB-C ROM. Okay. Five volts stuck on the T2. It's going to be stuck at either 0.045 or like 0.060. Right. It's going to be the T2 ROM. Okay. So you can see now what things can cause the stuck at 5 volt. So it can be the charger, it can be the connector, it can be the ISL, it can be this U1603, it can be the SMC. So and T2, we have other things that we need to check as well. All right. So T2. So the T2, right. So we have the CD32, and that gives power to the ISL, and it's a 9240, and that enables U7090, right? And that gives power to the PMIC, and that gives power to the T2, and the SMC is inside the T2 chip, okay? Right, and that talks to the T2 ROM, right? And USB-C CD32 chip and USB-C ROM. Okay, guys, so T2 CD32 chip gives power to the ISL9240, which is the charging IC, right? The charging IC enables U7090. U7090 gives power to the PMIC. That gives power to the T2. The SMC is inside the T2, right? That talks to the T2 ROM. Also talks to the USB-C CD32 chip and the USB-C ROM, right? So different failure points, yeah. Get the working conditions, check your chips, make sure you get donors in stock so you can check these things. Make sure you're using your multimeter, oscilloscope, logic analyzer, logic probe, etc. Okay. So get your working conditions, visual inspection, liquid damage, thermal camera, all these things, yeah. So let me see what we've missed. Okay. So yeah, I think we've covered quite a lot in a short space of time. What I'm going to do is I'm going to show you the different sort of tools that we use. Okay. So first of all, okay, we need to use the USB-C, EDP, and USB-C tester. All right. We need to use the BIOS flash tool. Okay. USB-C ROM flash tool. Okay, so there is other tools, but we're going to just look at these in the meantime. Okay, so I've already showed you this one, right? But we will sort of look at them again. Let me see. Right, so it's the S-UEM2. Okay, and we want to which is called the UBOS. Right, so the UBOS 2, you can flash the BIOS and flash the serial. Yeah, that's quite a good one. So UBOS 2. Okay. Let's see if I can show you on here. Yep, so it's the U301. Okay. Right, so UBOS 2, UEM 2, U301, right, and you get the BY200. E200. Yeah. Romania? No, I'm UK, man. Let me see if I can, because I'm not logged in. That's why. Oh, I am logged in, so if I change that, yeah, I don't know why it's just randomly giving me. Yeah, I'm not Andrew Tate, living in Romania, in top G. Top G, top G. Right, sound. That's the UBOS 2, and whatnot. Okay. So, yeah, that's the prices. But like I said, if you message me directly, I'll get the discount code. I'll give you the contact number directly so that you get the discount. But if you order it directly through the website AliExpress, you'll just be paying more. All right. So what I'm going to do is just go through this sort of quickly. Okay. So some models don't have a T1. So the A1708 2016 has no T1, only SMC. Right. A1989, 1819, T1 security, A1707, 167 has a T2 security chip. All of them have Retina, True Tone, 720p FaceTime cam, 16 gig, USB-C Thunderbolt. Yeah. They support Monterey, Venturas, etc., etc. So the T1 model, the T1 controls the camera, touch bar, touch ID. Same with the T2, but the T2 has an SMC inside it, so it has like control signals. Okay, with the PCH, the BIOS, right? The BIOS, the PCH, the SMC. Yeah, they all sort of talk to each other. So yeah, any issues with the BIOS, you'll get issues. PCH not communicating with the BIOS data is bad. BIOS also has SMC control signal as well. So if the BIOS is bad, then SMC won't work. So sometimes if you're stuck on 5 volt, you might have to, flash the BIOS and the T2 ROM and the USB-C ROM and replace the USB-C chips, maybe the charging IC, possibly U6903, the SMC, but there's also, you need to check the working conditions to see if there's any short circuits, bad resistors, continuity problems, maybe a reset line is stuck high or stuck low, depending on its logic. Yeah, so you have to be able to read the schematic. So say, for example, if a signal is active low, it should have voltage on it, yeah? Because if it's constantly stuck low, it means it's constantly stuck in a reset state, right? So the lines that are, so you have to understand, right, what voltage has there to be on this particular line, okay? So yeah, just make sure that you're understanding the schematics. But in future trainings, we go more sort of in detail how to read the schematics, the relationship between what voltages to check. Also within the hand skill, we can show you, like temperatures, airflow, that kind of thing. I can show you what paste to use, what stencils to use, all these kind of things. So yeah, let me see if I missed anything in relation to this. So yeah, so we've covered the amperes, stuck at 5 volt. So next week's training, we're going to look at the M1 models. So the M1, M1 Max, M1 Pro. We're going to look at how to potentially flash the BIOS, flash the USB-C ROM, flash the T2 ROM, how to actually do that. Check the power sequence for the M1 Max, etc. So yeah, we'll probably cover that in next week's training. But let's go back to the schematic in the meantime, and let's look at the sort of how we work this when we're checking it. So we have the page 1, which is obviously it shows you which pages have what on them. So the first thing when we go down, right, we can see is this page here in relation to USB-C. Yeah, so we just go one by one, So you can see here, remember I mentioned, right, that the Thunderbolt is part of the actual communication. So you have to be wary of that as well. So I'll put that here, number 9. Thunderbolt IC with USB-C ROM data. Okay. So Louis says that tester for USB-C and EVP is primarily diode test. Yeah, so it compares a good line to your line. And if you do get a discrepancy, then what you would need to do is actually check that whole line. Because say for example it's a short, you can inject voltage. If it's a partial short, then you can again check diode mode. Lift if there's a coil or a filter or like a fuse, you can lift one side to isolate the actual line to see if like there's a short on this side of the line, there's a short on that side of the line, for example. All right. So yeah, you check shorts, voltages, enable signals in that order that I told you. So you would check obviously the connector, the USB-C chip, ISL, U6903. Yeah, just do it in order. Do you drive a Bugatti? Uh, no, I don't drive at all, mate. No wonder Mac repairs are high value. What makes you say that, Darren? Because of the cost of like parts and the donor boards and the training and the tools and whatnot. Right, so if we look at the Thunderbolt and we look at the data lines, right? So if you see here, that says TBTX SPI clock, TBTX SPI MOSI, 3B3 UPC XBLDO. So you need to search these and work your way back, see where they go, etc., etc. Okay. So see, we search this one. Okay. Let me check this one. Okay. Check that one. And that goes straight back to the USB-C chip. Okay. But you can see here, you've got TBT USB power enable, TBT CIO power enable, I2C TBT SDA, SCL. You've got XWD lines. It's another sort of data protocol, uh, single wire protocol. That's why you've only got data and clock, 2 lines. All right. So if you have a bad Thunderbolt chip, then you will have problems. So let's look at the Thunderbolt on here. Yeah, so you would have to look at the ROM. And you can see where all the connections are located. Right. But if you look here, you have these lines that are also connected to the Thunderbolt chip. So anything that's TBT, so see this here, I2C TBT TS data, right? So that goes straight to the Thunderbolt. See that? Straight from that USB-C chip. So if there's data is bad on the I2C line, if there's no I2C communication between the Thunderbolt and the USB-C chip, then potentially It can cause, like, for example, like bad data, data loss, drop bits, um, just random sort of bad sort of data cases, data instances. Um, so yeah, so it's a good thing to have a donor board, because potentially, but most of the time it's going to be something like a USB-C chip that's bad, or it's like a connector that's bad. But the odd time you will get told, you might find that, right, there's say, for example, if you go to the U6903, right? So we know that the CD32 chip gives power to the U6903. U6903 powers the SMC, okay? But if you look at the line, it's called PP3v3G3 hot, okay? So if that line is shorted, then obviously it's not going to generate the voltage. That it's not the chip that's going to be bad, because what you need to do, you need to inject the voltage into the short. So if I go to a page which is the power rail page, okay. So what we need to do is we need to go through these rails one by one, right? So we start off from the top and just work our way down, okay? But if you notice here, one of the important rails is 3v3 G3 hot, yeah? So the main standby rails, then it's the 3v3 rail, you know? So if you don't have that, then if that's shorted, then it's not going to work. So you would have to inject voltage. So if you look at that line on the board here, okay, so if you look at all these components that are on that line, yeah, look, there's caps, resistors, ICs. So you need to inject the voltage, but obviously take the board out so you can check under the thermal camera on both sides. Okay. So this is when I'm talking about the working conditions. So you make sure that you check the board in certain areas, or all the full board, and also in different sections for shorts. Because sometimes that can be missed. The fact that you don't have a voltage is because there's a short there. And because the board is so big and it takes the heat, sometimes you need a really good thermal camera, or obviously you can inject quite a high voltage to increase the amps to see the heat. But if it's a voltage that's in relation to EMIC or the T2, the CPU, I wouldn't have too much high voltage, injecting into that line, just in case you obviously fry something else. Okay. Darren Lawrence, a lot of work and time. Yeah, it is, but sometimes we charge like 500 to like £1,000 sometimes for a Mac repair because of the data. The RAM and the SSDs are soldered on. So if you can't fix a board and the SSDs are soldered on, what you would need to do is that you would need to transfer the SSDs over to another board. And yeah, when you do that, it's going to be in DFU mode, so you need to plug it into like another computer, and yeah, do like a revive. You can choose like the revive option, and that'll install the operating system, but it should keep the data as well for you. So yeah, so you can do a transplant. If the SSDs are shorted and they're soldered on, then I can sell you. You need to replace the SSDs exactly from another donor board, and exactly from the position where you got them from. So you should number them before you remove them and put them back on the board in the same order. But they have to be working donors from a donor. But I have the SSDs. If I don't have it in stock, I can order it for you directly to and send it to you. So if it's like 4 SSDs or 6 SSDs or whatever, we can sell them as a package. So you don't have to buy the full board. All right. So instead of buying like a board for like £170, £200, I can get you a set of SSDs for, I don't know, like £60, £70, maybe something like that. But Darren, this is the most complicated repairs. A lot of the time, it's not even, you don't have to go to this trouble. So what I would do if I was you is stop the connectors, the USB-C connectors, which are not expensive at all. Stop the CD32 chips, which are not expensive. Some of them are, depending on what you would call expensive. But yeah, a lot of the time it's just a CD32 chip. Sometimes it's just a short, and you just remove a cap, and actually you're back up and running again. So yeah. So Lewis said, which chip enables Thunderbolt, or does Thunderbolt need to be operational before the USB-C starts working? So which chip enables the Thunderbolt, or does Thunderbolt need to be operational first before USB-C starts working? It doesn't need to be operational, but you do need to have a working USB-C because the data goes through there. So we're not enabling the chip, but we're using the chip as like a go-between. Okay. So if you open up the Thunderbolt page, there's a PC chipset, USB-C. Right. So, the answer to the question is, we need like power, obviously. So you would need to check the working conditions of the Thunderbolt chip. So power and enable, but everything's in the schematics. So this is where you have to understand what the word means, where to check, which part of the block of the schematic which you need to check. And that's where your own sort of skill and your own sort of learning and it comes into play, So let me see if I can actually find the Thunderbolt chip itself. So on here, the Thunderbolt chip is a UB1000. Right. So the way that we look at the Thunderbolt chip is that we look at it in two ways, right? So we look at the power, and we look at the general purpose I/O, the inputs and outputs, right? So we have these coupling capacitors here, right? And you need to make sure that they're working. So what you can do is you can check them in diode mode in both sides. Okay. So yeah, and also what you can do is if you think there's an issue, just replace it, or you can lift it on one side. So get these coupling capacitors, right? So what you've got here is the inputs and outputs. Okay. So anything that says DP is obviously going to be your display port, right? So the sync is the actually the device you're plugging into. So that would probably be like your monitor. Okay, so there's two ports, right? So you've got source, which is going to be your picture, obviously, from the internal screen, right? You've got LC GPIO, PLC GPIO, right? So if you notice here, you've got I2C lines, you've got the ROM, right? So if we copy that, paste, it goes straight to the TBT underscore T ROM. See it? Okay. That's the write protect. Right. And we have other lines there, right? So like SPI and the hold and MOSI and MESO, right? So remember, we know that those are SPI lines, so we don't really bother with the I2C. Okay. So the line that goes to the ROM is going to be the write protect line. So if we copy that, put it in here. Okay. So although that chip talks to the CD32s, right, through these resistors, also talks to the Thunderbolt chip as well. Okay. So it says here, laptop might charge and come on. So Louis says, so even if Thunderbolt isn't working. Yeah, no, the Thunderbolt chip, I mean, the Thunderbolt chip obviously does a few different things, doesn't it? So it depends on which function that you actually want. So if you want an external display, the Thunderbolt will actually sense, what's plugged in and output the display. If it's only a charger that's plugged in, then the write protect line is going through the Thunderbolt. Yeah, and then it's going to the ROM. So if you have a ROM data issue, then potentially you could have a problem with the Thunderbolt. Okay, so what you can do though is think about it as on a left side and the right side, right? So say for example, the laptop doesn't charge, the MacBook doesn't charge, or the right or the left side. Okay, then you have to think, right, there's an overall problem. Let's check the working conditions. But see if there's one side working and one side is not, that means the working conditions are good. there's a problem with that one side. So it could be the USB-C ROM chip, or Thunderbolt, or it could be the resistors. Yeah. Could be the connector as well. So you have to separate if it's only the left side or only the right side, or if it's both, But replacing the Thunderbolt is actually sort of rare. But you know that it's when you look at the schematics, when you start copying pasting lines, you can actually see what's what. So you can see that you have enable lines, right? So this is where GPIO 0 to 8, and then 0 to 6. All right. So you can see here an input, power enable, S3, bat low, USB power enable, right? So it says here PU at the PCH, right? So if we search that, okay, so this is the PCH here, U1100, right? And see how that's an output signal. See that there? Right. So the PCH is turning on all these different lines, right? So you've got the right side, left side. Sometimes you get two Thunderbolt uh, chips, right? So you really need to copy and paste, use a schematic, search, being able to understand the power sequences. PCH, right? So this is actually the CPU, U0500. Yep. So that's the CPU. That's the GPU. This is the PCH, U1100. Right. So that's an enable line for the UB300 USB-C chip. Right. So this signal's coming out of the CPU on this particular line, and it's going into the Thunderbolt as well. And it's going into the USB-C chip. Right. So if you look at like another line here, you can see. So let's go back to U1100. and then we want this line. Right, so the fastest way is to search this line is to go back to the U30-100. Right. Go back to the USB power enable. Okay. So that USB power enable signal is coming out of the PCH as well. Okay. Okay, so that's the TBTX USB power enable. And then also it's going into the Thunderbolt. And it's going into the USB-C chip. See that? But that USB power enable won't go out until the PCH has its own inputs, so the PCH needs power, needs clock. It needs to be told to go from S5 to S4 to S3. See this here? S5, S4, S3. So that's output. So the inputs are going to be these power OK signals. PCH power OK, sys power OK, system reset, PLT reset, RSM reset. All right. Then you got SLP S0L. So that's when it's fully on. You'll have that signal. So you won't get this here until the PCH is actually turned on. All right. So I know it looks like a lot to check, but if you can learn how to condense it, into right, I could check the start, the middle, and the end, or I can check the end, the middle, and the start, or the middle. But you have to start somewhere and knowing how to check and be able to sort of condense that. But see, in my paid training, we go more in depth into like the voltages and the actual power sequence. Because it takes a while to go through each page and to show you the sort of links between one chip to another chip, etc. So yeah. So what I'm going to do is it's 9:30, guys. We're going to leave it at that because we've been on for 2 hours now. What I'm going to do is we're going to carry on next Tuesday, okay? And what we'll do is I'll create an event on Facebook for next Tuesday, 7:30 UK time. And what we'll do is we'll finish off where we sort of left off. But like I said, I want to sort of go on to the M1 chips. All right. But what we'll do is we'll actually go over this again as a refresher, and then we'll carry on with the sort of the M1 chips. But obviously, in terms of working conditions and whatnot, we will go further into that because there is some questions that the chat have asked about. Obviously, the relationship is between thumb chips and enable signals and whatnot, but there is a power sequence, there is a signal sequence, and yeah, you don't have to memorize it, but the more you work on these and the more training you get, then obviously the better you become at sort of remembering everything. But try and take notes and obviously write things down as you go along. Create your own documents and your own knowledge base. But it looks daunting when you look at the board, but it's not really. I mean, you've got a CPU. We know from our basic computing classes, you've always got a CPU, you've got memory, RAM, storage, clock. So yeah, you can narrow it down. But essentially, I mean, if the board is dead, obviously we know, right, there could be a short somewhere in a power rail. Based on the DCPS and the voltage, we can look at things like the connector, the USB-C chip. We can look at the USB-C ROM. We can look at the Thunderbolt connector. Also, we can look at, this is the charging IC. Okay, so we can check the working conditions. We check power going in. We can check power going out. You know, we can check enable signals, check data, reset lines. And then the power from there goes to this here, U6903. And that pretty much gives out the 3v3. Yep. This is the G3 hotline. Right, so we can see where the power goes. So that power goes to the USB-C chip. Okay. It also goes here as well, which is the U5000. Right, so it goes here, here. USB-C chips. Yep. So that chip is the SMC, the U5000. See that SMC, right? And there's two sections, section 1, section 2. So that first section is all your general purpose inputs and outputs, like your reset signals, your input signals, your LPC lines, SM bus, fan control, on and off, sleep. So if you notice here, you've got PM, SLP, S5L going into the SMC, right? And where does that come from? Yeah, so it comes from the PCH, right? So you only get an S5 signal if your PCH is working, and then that goes to the SMC. And the PCH, the SMC control signals inside the BIOS chip. Okay, so like I said, the BIOS, PCH, SMC all talk to each other, especially to turn on. But you can only turn on if USB-C, if your battery's got power. But if your battery doesn't charge, then it's a different troubleshoot for that. Because if you can get it on with a charged battery, then it's a different story, you know. So, but anyway, I can sort of go on all night. What we'll do is I'll create I'll upload the notepad to my Google Drive and I'll share the Google Drive. So I'll do that just now. So hey guys, I've put a link for that notepad in. Can somebody test that link for me, please? And just confirm that it works. All good, guys? Nice one, Tabes. Right, okay, guys, so I'm going to finish up there. So just to sort of finish up, um, first thing, if you need any tools, message me. I'll get you a discount. I'll get you a discount code referral. If you need to buy any tools, any sort of you know, questions or anything, just obviously ask. We'll be doing training again next Tuesday, 7:30 p.m. same time. If there's any videos in between that, I'll let you know. Um, if anyone wants one-to-one training, face-to-face training, want to do long-term training, mentorship program, then yeah, just PM me. We can discuss that. Um, so yeah, like I said, if you need any tools, information about training, if you need training, private, one-to-one online, long-term, more in-depth training, because these are just sort of the three sort of basic trainings, but we do go sort of more in depth. I do have students that are currently studying, and they do obviously these online, but they also do face to face in my lab as well, and also I mentor them privately. So yeah, we can sort you out with that. So yeah, next week, guys, I'll see you then, and also what we'll do is I'll put the link in for next week's um, training. So what I'm going to do is if you got any questions, Q&A or anything like that, just ask you. And if you want to leave a tip, then you can PayPal me. Um, what I can do is I can upload my PayPal link. and yeah, feel free. And if there's any sort of specific questions or specific things that you want to sort of ask, like I said, yeah, might be better to sort of join the sort of training program. Like I said, I do sort of long term as well as the the short term courses, you know. But yeah, if you want to PayPal me, I'll just send you my email, which is cgentuk. Okay, guys. So thanks for sort of yeah coming tonight and joining the training. And yep, I'll hopefully see you next week. So Louis, Dan, Simon, Tabes, who else is here? Simon, Dodiomi, and who else was here? Was it Phone Medic was in at some point? Yep, Phone Medic, Abdullah. Nice one. So hope to see you again next week, guys. Okay. I'll catch you later. Cheers. Bye bye.